This one is about movement, and I played back my last recording of it. It was too late at night, and I realized there were a lot of mistakes. So now this is the refined version. Basically, we've gone through at this point what the interface looks like, how to use all of these patches, how to interconnect them, the different types of patches that exist, and a little bit about how to put images and movies on the screen, how to play sounds, all these things. And we still haven't talked about time and movement. So this is really one of the things that Quartz Composer does best. So now we're going to talk about it. So I've got a new composition, and what I'll do is just start by adding a circle, because it's easy to see our movement by just adding a circle there. Plus it looks kind of nice. It has this shading. You can change all of that stuff in the patch. And then there are a few patches that I want to talk about that involve time, which is what we need. We need values to change over time. And to prove that, I can just go into the parameters for this circle, and if I look at the Y position, I can see that by changing the dial, I'm able to basically add some animation. I think maybe if I could get it to go down to, say, minus 0.5, and then up to plus 0.5. Maybe I'll make this 4:3 so it stays on the screen. So that's the range I'm looking for. Just to be kind of nice about this, it's like 0.5. I could get it to actually touch the end of the screen, but let's say 0.5 to minus 0.5. And you know, I could sit here and do this, but obviously I wanted to automate this change of numbers. So you can see these numbers have a lot of decimal places. We need a value that is continuously changing and is really fluid. So let's try and make that happen. There are several patches that we can use to do this, and I'll show you a few that make sense for this conversation. So here's integrator, and then we'll talk about interpolation, and we'll talk about the wave generator, or low frequency oscillator. That's what LFO stands for. Term common in when talking about audio, but that's not what we mean in this case, but very similar. Then timeline. Let's show timeline. So I'll show each of these in turn. Integrator is very simple, and I'll just open the parameters, get rid of the library, and there's a value. It starts off with 0, which is kind of strange to me. If I started at 1, let's take a look at what's happening. We'll add an instruction patch here, and we should be able to see whatever number is coming out of there. Instead of hello world, we should see a number a little bit bigger. So we'll take that output and tie it to text, and we see that it's basically a number that's just going up and up and up. It started at 0 because I just connected it, but what you'll see is that it actually starts at 0 every time I hit run. So it's a number that's going up. It looks like one whole number a second with lots of fine resolution in between. So we're at about 60 frames per second, and every one of those frames that goes by, there's another 60th or so of a new of the next integer. And so this is just showing you that it's a really fluid kind of movement. And in fact, what I can do is if I stop this and tie this also to my Y position, I will see it go from 0 continuing up. Now it's going to go up until it gets to 1,000,000, which is way off the screen. So it's alone, this isn't useful, but of course this is starting to do the kinds of things that we want, automating numbers. And integrator is really useful in other ways, and we'll see it again before the video is done. So that's how integrator works. Oh, I should say that you can change this value. If I set it to 10, what that means is that it takes 10 seconds for it to get, is that right? 10. No, there are 10 numbers every second. So it goes up 10 whole numbers every second. If I change that to 0.1, it actually takes, so it's a tenth of a number every second, which means it takes 10 seconds for it to go up one whole number. So we can change its speed. Get rid of that, and well, let's talk about interpolation. Interpolation is pretty easy to use. It gives you a start value and end value. You provide those, and then tell it how long it should take to go from 0 to 1. Now if I just tie this right to Y position, and I'll connect it to the instructions just to show the same thing happening. Basically it looks pretty similar to what we just had, except that it's repeating. So it goes from 0 up to 1, and then it starts over again. The reason why it goes the speed that it does is because of the duration. I could say it's supposed to take 10 seconds instead of 1 second, so it goes a lot slower, but it still does this repeating when it gets up to 1. And the reason is that because it's set to loop. I could say it's a mirrored loop, in which case it'll actually go back and forth. Kind of nice already. And then I can, well, I said I wanted to go from minus 0.5 to 0.5. So why don't we make it do what we were planning? And then the last thing is this interpolation. So you can choose how, if you notice, it's a really sharp bounce that it does on each end, and that's because it's linear interpolation, and I'll show you what that looks like. But basically, we're talking about a waveform that looks like a triangle, so it's going up and down with these really sharp angles. A sine wave, which kind of, I'll give you a quick sneak preview of this. This is a sine wave, so if we have that kind of fluid motion, then we should see that ball slowly come to the end and then slowly start up again, picking up speed. So let's try it. If we do sinusoidal in, what that means is there's a sine wave on the bottom, but then it's a sharp point at the other end. So if you imagine this wave being really curved on the bottom and then sharp up here, and then curved and sharp, that's the kind of wave that we have. We can actually see this if we go into the patch inspector for interpolation and choose settings. We can see it has a curve in the beginning and then it's sharp at the end. Let's try some other curves. If we do exponential in and out, it's going to look different. That's interesting. And then if we look at the settings, we'll see what that looks like. It's kind of a exponential picking up of speed and then an exponential slowing down. And of course, this just continues in that same wave. So that's basically everything you need to know about interpolation. This works the same way if I chose to loop only, well, if I say there's no looping, then every time I start this again, it'll do it, but it only does it once and then it just freezes. So again, it's worth noting that all of these patches that deal with time are tied to the run and the stop. How do I get it to go again? That's a question for later in the video. Okay, let's get rid of interpolation because we know how that works, and then we'll go on to the wave generator, which is a little more complicated, but it kind of does the same thing for us. Let's see what this does. If we just take this result and feed it to text, and then also connect it to the Y position so we can see the results. Look, it's already going up and down. So a wave generator, you know what a wave looks like. An ocean wave sort of continually goes up and down, and that's what the wave generator provides, numbers that go up and down constantly. I can't really see what those numbers are. Maybe I'll add a number formatter in there and make it a little bit clearer. So if I take that result, make it go to the number formatter, and then make that go to the text instead, I can see those numbers look like they're going from 0 to 1. And I can see it up here too, but with more decimal places. So that's not exactly what I wanted. I wanted to go from minus 0.5 to 0.5. Now's probably a good time to take a look at the settings here. So it is a sine wave. I've got different kinds of waveforms. I can have it go up and down in this really pointy wave. A square wave actually is just turning on and off. So it goes from 1 to 0, 1 to 0 with no variation in between. So that could be useful. And especially if we want to flash something on and off, of course. So let's try the sine wave again and take a look at first period. You can guess what the period is. The period is how long it takes to make one of these full cycles from the middle of the wave to the next middle of the wave. So it's kind of a complete traversal of this wave. That's the period. That's how long it takes. So we can kind of see that. It takes 1, 2, 3. It takes a second each time. The phase is basically where this wave moves horizontally. It would look the same, but it would kind of move horizontally, which for us most of the time doesn't matter as much as these other settings. But amplitude is very important. Amplitude is basically let me just make a new equation here, and I'll say it's the sine of x. That's what that looks like, the black line there. I'll get rid of the other one. It doesn't look exactly like we have this. What we have, this one goes from -1 up to 1, and we've decided that this one goes from 0 to 1. And also, it takes a really long time to do it. It seems to take amplitude is the height of the wave from the middle to the top. So this has an amplitude of 1. That's an amplitude of 1. It goes up 1 from the middle of the wave to the top of the wave. Here I've got an amplitude of 0.5. So that explains a difference already. You don't have to worry about how this works, but if I do, if I divide this whole thing by 2, now I've got an amplitude of 0.5. So it goes from 0, the highest it goes is 0.5. That also means, though, that it goes to negative 0.5. So it goes negative 0.5 to 0.5, which is kind of what I want, but that's not what I'm getting. I'm getting 0 to 1. So how does that happen? If this wave is sort of correct, of course, the distance, the amount of time that it takes is not right, and I can make that happen. I'll just actually, let's look at the other wave. This is what we want, right? So we want it to go from 0 to 1 over the course of 1 second, and that seems to be what this is doing. So how did we get there is the question. Well, if we look at this wave, and we can see that it goes from negative 0.5 to 0.5, how do we get it to move up? That's all we need to do is push that black line up so that the lowest point is 0, and then the highest point will become 1. That's what we've got in the blue line here. So the way that we do that is with offset. So the offset is literally taking that wave and bumping it up 0.5. So if we change the offset to 0, we'll see a change immediately. It goes from negative 0.5 to 0.5. So that's kind of what we wanted here. I can fix this by getting rid of the offset, stopping it from nudging upward. So now we've got basically the wave that we see here. So that's just, I'm not a math person, and you don't have to be. You can ignore all of this grapher stuff. By the way, this is a tool that comes with the Mac OS X. It could be useful to you. You kind of fudge it around, and you could maybe make a wave that looks very weird by tampering with this and then try and figure out how to make that happen here. I don't know how that would happen. But you can start to figure out how this works, or you can just tinker until you get the results that you want, I suppose. So this is doing what we wanted. Okay, so that's how the wave generator works. It's worth spending a little time to understand what amplitude and period and offset mean, especially if you intend to do anything with sound, because those waves are just like sound waves. So the last one I want to show you is timeline. And what we can do is, if we look, there's actually no input parameters for timeline. There's nothing on the left here, so nothing shows up in the parameters panel. I'll get rid of the parameters panel and look in the inspector. Same thing. There's nothing here for input parameters. But if we go to the settings page, we can see that there's actually, this is where all the magic happens. So let's go back to adding an instruction here, and we will tie that output to the instruction, and we can see what it's going to do. And then we can also set it to, or feed it into our Y position. And again, we have to hit stop and run. And what happens? Well, exactly what the settings say. It goes, this is time. So over the course of 1 second, it goes from 0 to 1. And it does it in this really nice smooth curve. So let's try that again. Is that what's happening? Yes. It's kind of a smooth takeoff, and we don't see it slow down because it's off the screen, but it's a smooth takeoff, smooth transition to 1. So where are we now? We're probably like 15 seconds into the sketch, this composition running, so we're way out here on the timeline. But this line, at this point, it never changes, so it's staying at 1. And you can see that here. It hasn't changed. It just stays at 1 forever. So this is not a very interesting curve, and the interesting thing comes when you expose this little area here, and it tells you how to add and modify this whole thing. So and this is interesting. You can see it moving right now because what I'm doing is changing the forever result by moving this around. So let's just zoom out in the time scale, and we'll say after 5 seconds it should be back down to 0. So it goes up in a nice smooth way and then linear down to 0. Let's see what that looks like. Up, and then a slow linear going down to the value of 0. And it stays there. So that's how this works. Now, that's everything you need to know about these few patches, but it would be nice to know how we can get it to not be tied specifically to the run and stop. And this is crucial. So we're kind of starting on a new topic for the last 2 minutes of the video, which is how we can manipulate So there is a way for timeline, interpolation, wave generator, all of these time-based processor patches for us to fool it into thinking that the clock is actually different than it really is. The clock is called patch time, and there's actually a patch called patch time. If we look at what patch time is, all it is just a smoothly changing number that counts from whenever I hit the run button. So all of these time-based patches run according to patch time, which is kind of like the clock time. Well, what if we fooled it into thinking that the clock was actually going slower than it really is, or that it was going backwards, or that we could start it over by clicking the mouse, or we could start it over after 10 seconds. There's all kinds of possibilities. And the way that we do that, this is sort of like not obvious. You right-click on the patch, you hit time-based, and you change it to external. It adds a new input here, and now we're going to feed it what we want it to think the clock is. So how could we do that? Well, we know about one patch that actually counts up from 0, right? And we can make it count up in a normal way. Let's see what that looks like. Counts 1, 2, 3, because I put a value of 1 here. So if I tie that to patch time, there's really no difference, because my integrator is doing the same thing that patch time does. It counts up from 0 when I hit run. Well, there is, however, a reset signal on the integrator. So what if I connect my mouse left button to the reset signal? So now, every time I click the left mouse button, it starts time over. Or at least the timeline patch thinks time is starting over. So this is kind of the same as if I had just stopped and hit run. Time is starting over. So we're actually manipulating what this patch thinks time is. It's kind of nice. Like once it gets down there and it rests, it's sitting at its steady value of 0, was it? I think 0. It's sitting at 0, and I can click the button and make it start that whole timeline over again. Okay, so the last thing I want to show you is a separate sketch that composition that I created called ball bounce, and all it is another circle with a timeline. But this timeline, if we look at it, looks like, well, you can kind of guess what's happening here. Let's fit everything in. So it's starting at 1.5 and it's falling down, hitting 0 and jumping back up, hitting 0, jumping. This is a drawing of what a ball looks like being bounced across the room. And that, if we tie that to our vertical position, that's exactly what we get, is that kind of animation. By the way, you can change the name of this this number that's coming out. You see mine says vertical position. There's a weird bug, it seems. You actually have to double click on it and then just type and hit enter, and then it changes. It doesn't seem to work properly, but there it is, so it's changed. Once you add more and more, because you can have another, let's add a new timeline. You can add more. Oh, I think you have to name it. I'll call it second. I can add a new one here that has some weird kind of action to it, and now I have a second output. So maybe that's the X position. That would be interesting. Let's see what this looks like. Pretty nice. How can I get it to start over when I click the mouse? Well, what if we add an interpolation as its external time base? Starts over. And why is that? Because my interpolation actually, so I used the integrator before. It went from 0 and just kept going, and I was using the mouse to reset that. But interpolation works too, because it goes from 0 to 2. I'm only using 2 because if we look at the timeline patch, it seems to be done bouncing around 2 seconds. So it bounces, it rests for a split second, and then